The law of sines. What if the triangle we want to solve is not a right triangle? In the next section or two, we will develop ways of solving these triangles. If you know at least one side and the other two pieces of information, sides or angles, or one of each. We'll label these triangles besides A, B, and C and use the Greek alphabet counterparts for the angles opposite those sides as shown above. You can draw a perpendicular line and call it H. We do this so we have a right triangle we should really know how to work with. And then let's write some trig functions so we know the right angles formed. So we have here our sine of alpha opposite over the hypotenuse. And the sine of gamma, we have the opposite over the hypotenuse. Solve for h, there and there. Since they're both equal to the same thing, they're equal to each other. And from here we can perform we can simplify it by dividing both sides by A and C. And the result is the beginnings of the law of sines. Now we can drop a perpendicular from another place. This process can be repeated, dropping a perpendicular from a different vertex of the triangle. What we get, we combine these, is here, the law of sines. What this says is that you can set up the ratio of the sine of any angle in a triangle and the side opposite it, and it will equal the ratio of the sine of any other angle and the sine opposite it. If you know 3 of these pieces of information, you can solve for the 4th. You may have an angle, a side, and then another angle. The 3 possible configurations, let us use law of sines as shown here. Angle, side, angle. Side, angle, angle. And side, side, angle. What this means is that you need to already know an angle on the side opposite it and one other side or angle to use the law of sines. In this case here, you don't have an angle on the side opposite, but you can use subtraction here and find that 3rd angle. So now let's work some examples. So draw a triangle, label it. Replace it with values here. Okay. It's the side angle, angle. You know, we have an angle on the side opposite, and the law of sines will help. So we do have an angle on the side opposite it. So we can set up a proportion here and solve for the missing variable. And it gives us one side here for B. What about alpha? So we have 2 angles here. We can subtract and find the 3rd angle. There's a 3rd angle there, 43 for alpha. How can you find A? It's not a right triangle, so you cannot use Pythagorean's theorem. You use law of sines again. And cross multiply and divide. And there's our A. So everything is labeled. Now let's look at a triangle. You have side angle. You can have possibilities here. It could be that you can't get all the sides to join with the given information, so that there will be no solution. It could be there's only one triangle that could be formed, and you can solve for the triangle. In this case, A, B, and alpha are the same in both of these triangles. It could also be that since side C and gamma are not given, there are two ways to draw the triangle, and therefore two different solutions to the triangle. It's easy to remember that the tricky ones are side angle. Okay. So, the no solution case will be obvious when computing, as we will see. In this case, we have a beta is 95, B is 4, and C is 5. We label it. We know an angle and a side opposite, so we can use the law of sines. Cross multiply and divide. Take the inverse sign here. And what happens? As it turns out, inverse sine function goes from -1 to 1. And since what this means is that there is no solution here, you cannot build a triangle like this with these dimensions here. Look at another case here. Beta is 35, B is 6, and C is 8. So you draw our triangle, we label it. Okay, we have side angle, so it could be no solution, one solution, or two solutions. We set up a proportion here, and we can solve for gamma. Take the sine inverse. Okay. And it gives us sine inverse is going to be 49.9 degrees. So that would go there. Can you find alpha? You have two angles. You can subtract off and find the third angle. Can you find A? You can use the law of sines again. Cross multiply and divide, and there's our A, which is 10. Smallest angle should have the smallest side opposite it, and the largest angle should have the largest side opposite it. Since this was a side angle triangle, I need to check to see if there is more than one solution. Remember, your calculator only gives the answers on the unit circle, and it has a sine value of 7.765. You need to figure out where the other one is and see if you can make a triangle with it. So here we have. You can draw it and see. We found it to be 49.9, and you see there is another angle here. Okay. What is the angle going to be? 180 minus 49.9 gives me 130.1. So the second angle there is 130.1. See, knowing beta and gamma, knowing the two angles here, can we find the third angle? You can find it by subtraction, 14 degrees. Can you find A? Yeah. Yes, we can. Law of sines again. Cross multiply and divide. A is equal to 2.69. Let's look at another case here. Solve a triangle where beta is 42 degrees, B is 22, and C is 12. So you draw a triangle and label it. And you can use the law of sines here. We have 42 and 22, cross multiply and divide. The inverse sine. And this tells us that that angle is 21.4 degrees. So knowing two of the angles, can we find the third angle, alpha? Yes, by subtraction. It's 116.6 degrees. Okay. We got three angles there. And we can find A. Here, using the law of sines again. We can cross multiply and divide. Tells us that A is 29.4. Okay. Since we have side-side angle, we need to check the possibility, the other sine value of possibility of a second triangle solution. So 21.4. You have a second angle there. So how do we find it? 180 minus 21. 158.6. So the other angle is 158.6. So and you find the third and subtract off. And in this case here, we have a negative number for alpha. The negative number tells us there's no second triangle, and this is a one triangle solution. It's not possible to build another triangle with these stipulations on it.